The second part of chapter 11, we're going to focus on volume. So today we're just going to do volume of prisms and cylinders. So by the end of this lesson, you should be able to apply the formula for volume of a prism and for volume of a cylinder. So remember that volume of a 3D figure is the number of non-overlapping unit cubes of a given size that will fill the interior. Basically, it's all the space inside of something. So if we measure the outside dimensions in centimeters, it's talking about how many centimeter cubes, centimeter by centimeter by centimeter, can we fit in this space. So the volume of a prism is base times height. So you figure out the area of the base, and then you just multiply it by the height. Where before, remember for surface area, we had to find the perimeter of the base and multiply it by the height. This time, we just take the area. So it depends on what kind of base we have. If we have a rectangular prism, it's length times width times height. The length times width gives us the area of the base, and then we still multiply it by how tall it is. And if it's a cube, everybody's the same, so it's just length times width times height ends up being s times s times s, or s cubed. So find the volume of the prism, round to the nearest tenth if necessary. So volume is the base times the height, or in this case, length times width times height. So all we got to do is multiply these things together. So 13 is the length, 3 is the width, and 5 is the height. And we get 195. And because we multiplied centimeters times centimeters times centimeters, our units are centimeters cubed. For area, it's always squared, and for volume, it's always cubed, so keep that in mind. So let's find the volume of the right regular hexagonal prism, round to the nearest tenth if necessary. So we have to remember volume is base times height. We know that the height is 12, and the base is a little more difficult to figure out. Because it's a hexagon, we got to think back to chapter 10. They tell us that this is 9. And remember, area of a hexagon is 1/2 ANS. So A stands for the apothem that we don't know, N is the number of sides, and S is the side length. So we have half of what we need. We have to find the apothem. So we have to recreate this triangle. Because it's a hexagon, remember that there are 360 degrees total divided by 6, and then cut that in half. That means this guy's 30, and we're looking for this. So we want opposite over adjacent. And if we plug this into our calculator, we end up doing 4.5 divided by the tangent of 30. So we get that our apothem is about 7.8. So then we can multiply that by 6, by 9, and then by 1/2. And we end up with the area of our base is about 210. And then we have to multiply it by the height, which is 12. So we end up with the volume of this hexagonal prism to be about 2,525.3 feet cubed. Find the volume of a triangular prism with a height of 9 yards, whose base is a right triangle with legs 7 yards and 5 yards long. I'm going to leave this one for you to do, and we can go over it in class. So let's talk about cylinders. The volume of a cylinder is exactly the same thing. It's base times height, except cylinders are special because the base is a circle. So you could write it as pi r squared h, or you can just remember base times height for all of these. So find the volume of the cylinder. Give your answers in terms of pi, rounded to the nearest tenth. So one thing that's important is it doesn't matter if these shapes are tilted as long as you have the actual height of it. Now if you had this right here, you would have to have a little more information so that you could figure out the height. So we know the height's 14, and then the diameter is 18. Because volume is base times height, and our base is a circle, I don't need the diameter, I just need the radius. So we got 9 there. Pi times 9 squared times 14. So we'll end up doing 81 times 14. And I get 1,134 pi inches cubed. And then they wanted it in terms of pi and rounded to the nearest tenth. So we're going to multiply this by pi and get 3,562.6 inches cubed. So let's try a little tougher one. Find the volume of a cylinder with a base area of 121 pi centimeters squared and a height equal to twice the radius. Give your answer in terms of pi and round it to the nearest tenth. So remember, if you have a cylinder, it means that you have a circular base times the height. So they tell me that the base area is 121 pi centimeters squared. So remember, a circle is pi r squared, and if that equals 121 pi, I can solve for my radius. So the pi's cross off, and if I take the square root of both sides, I get that my radius is 11. And then this tells me the height is equal to twice the radius. So 2 times 11, or 22 centimeters. So now we have all the information we need. Remember that volume is base times height. They told us the base was 121 pi, and we just found the height to be 22. So they want us to find it in terms of pi, so we'll do 22 times 121. Gives us 2,662 pi centimeters cubed. And then also 8,362.9 centimeters cubed. Remember, these mean the same thing. One just is exact in terms of pi and one's rounded. So let's talk about changing dimensions. If you remember, if we change dimensions and we talk about the area is that change squared. And that's because when you talk about area, it's a 2D surface and you get units like inches squared or feet squared. So guess what happens when we change the volume? If things end up being inches cubed or feet cubed, we're going to see that's what happens to our volume. So the radius and the height of a cylinder are multiplied by, it should be a 2 there, describe the effect on the volume. So let's actually find this and prove it to ourselves. So if we have this original cylinder here, the volume is base times height, pi r squared times height. So we have pi times our radius, which is 24 squared, times 33. And if we throw that into our calculator, 24 squared times 33 gives us 19,008 inches cubed. Oops, we forgot pi. So that's the original one. And then we're saying that everything's multiplied by 2. So my radius is now 48 inches, and my height is now 66 inches. So let's plug it in the formula again. So pi times my new radius squared times my height. So 48 squared times 66 gives us 152,064 pi inches cubed. And now if we want to compare these, all we have to do is divide them. And you end up with a difference of 8. And that reason is 8 is 2 cubed. So Remember, area is the change squared. Volume is the change cubed every single time. So if something gets 4 times as big, you cube 4, and that means your volume is getting 64 times as large. So composite figures, these are way easier than when we do surface area because you just care how much space this fills up. You never have to subtract anything out. When it looks like this, you're just adding stuff together. So you have the prism on the bottom and the triangular prism on the top. So let's just look at the bottom. How much space does that take up? So remember, it's base times height, or because it's a rectangle, length times width times height. So I have 8 times 4 times 5, which is 160 centimeters cubed. And then the thing on the top is this nice triangular prism. So our base needs to be one of these triangles. And unfortunately, they don't tell us a lot of information. They tell us that this is 8, and then this one back here is 8. We know that this is 8 as well. So in order to find the base, we're missing one piece of information. So this base times height is really 1/2 base times height of the triangle times the height of the entire prism. And the height of the entire prism is going to be this. It's going to be the 4 there, this distance here. So we need to find the height of the triangle. That we don't know. So we know that all these sides are 8. We're looking for this. Now there's a couple different ways that you can do this. You can turn this into a 30, 60, 90 triangle, and remember that this is going to be whatever this length is, cut in half, and then multiplied by the square root of 3. Or you could use some trig, or you could use Pythagorean theorem, but you end up with that height being 4 times the square root of 3. So we have 1/2 times the base of our triangle, times the height of our triangle, times the height of our prism, which we said was 5. And because this says to round to the nearest tenth, we're just going to type all of this into our calculator. So we'll do we end up with 138.6 centimeters cubed. Now remember, this is just the triangular prism that's on top. So if I want to know this whole composite figure, all I have to do is add these guys together. And you end up with 298.6 centimeters cubed. So I'm going to leave this one for you to do. And this one you do have to subtract because you have the cylinder and then you want to take out that prism that's inside of there. So try that one on your own and we can go over it together. This real world example has you find the volume, but then it wants you to use the density of water and the volume you found to estimate the weight of the water in pounds. So this one's a little tougher, but give it a try. So you should be able to apply the volume formula for prisms and cylinders on the simple problems and then give the other ones a try. Make sure you write down any questions you have and we can go over them together in class. Enjoy your night.